All right, guys, let's get started on project 3. All right, so here we are with our ANSYS workbench. We are going to start with a new block, new system. First things first, we are going to go into geometry and we're going to change this into 2D. We are told in the project guidelines that it is a 2D geometry, so of course our analysis type is going to be in 2D. So the first thing we're going to do is go into Design Modeler and wait for that. Okay, so now we are in Design Modeler. All right, so what we are going to be creating is a flow between a top plate and a bottom plate. We're going to be moving them in different directions. So to create that, we are going to make a rectangle. We are going to start from this origin point. And you can kind of make it whatever, because right now that doesn't matter too much. And we are going to, I like this one, we're going to dimensionalize it now. So this one is kind of up to you, what you want to do with it. It says that the length is going to be 150 times the height. Oh, another thing that we should do is change our, yeah, we're going to turn these units into millimeters. Uh-oh, lost this a little bit. Let's go back to it. Alright, so let's dimensionalize. There we go. And then do this one and do this one. Okay, so this first one, let's do, how many millimeters? 2 millimeters. That would make our height needs, our length needs to be 150 times the height, which would make it into 300. That is so funny. Okay, so we're going to do surface from sketches, and we are going to, so here, this is our application. We're going to apply it, and then we're going to generate. And here we go. Here is our sketch. It's very interesting because it's so thin, but the length is so long that it'll be okay. Alright, so I believe that should be it for the geometry. We can kind of close that out now. Give it a little update. Okay, next thing we're going to do is go into our mesh. It's going to take a second. Alright, so now we have our meshing set up. Very exciting. So the first thing that we're going to do is just insert a basic mesh on the body. Gonna apply, generate. Alright, and then the next thing that we're going to do is going to be creating divisions along this object. So actually, okay, here we go. We're going to click on the edge. We're going to use this one, and then you're going to want to hit Control. My goodness. Okay. Anyways, hit Control, and we're going to click second edge. All right. So, okay, 2 edges. Doing number of divisions on this one. Let's do 70 divisions. No curvature capture, and the behavior is going to be hard. Alright, that should be good. Now we're going to add another sizing over here. Not exactly here per se. It's going to be the top and the bottom. So top and control bottom, apply. Number of divisions, this one's going to need a lot. Let's say 500. There's going to be no curve capture, and it is again going to be hard. You can see all those divisions. Okay, next. Okay, so, wow. Oh my goodness. Okay, so the last step I'm going to do is going to be a face mesh. We're doing that on the entirety of the face here. And that should be it. Okay, so now that it's done, when you look at it like this, it looks like just a big black blob, but when you zoom in, we have all of these rectangular divisions throughout our bar, and that is super important because that means we're going to get a really good analysis in the next step. Alright, so last step that we're going to do in here is going to be naming our edges. We're going to make things much easier when we get to the next part. Okay, so this is obviously, do like this, create new section. This is going to be our inlet. Okay, this right here is going to be upper wall. This one is the lower wall. Right, and then we've got one more thing to do over here, and that is going to be the outlet. Alright, so, and then of course we are going to want to select the whole body, and we'll just call it, this is going to be called the body, just because that's what I feel like calling it. Alright, so that should be it. What I wanted is to update this mesh because we just did a lot of things. Should be good. Alright, so now we're going to go into our setup. Alright, so we know it's 2D. We're going to put in double precision, and 2 solver processes. This is the real meat and potatoes part. Alright, so now we are finally done, and just to give it one more check, our mesh, very fine mesh, looks good. We've got inlet and outlet, and now it's time to start putting in our simulation actual values. So first things first is we are told this is a laminar flow, so make sure that that is properly put in there. I'm just going to double check it. Alright, materials, the fluid as air. You can, it does say that you can put in any fluid as long as the Reynolds number is 2,500, but I'm just going to keep it as the air they have here. Yep, and it should be good for our Reynolds. Alright, so next thing is going to be changing the inlet velocity. In the directions it says free stream incoming velocity. Let me show you right here. Free stream incoming velocity of positive 5 meters per second. So let's go ahead and put that in. 5 meters per second. Apply. Apply. Close. Double check it. Okay, so we're good. Okay. And then we've got a top and bottom plate. So lower wall, it's going to be a moving wall, and the absolute speed, which one did I click? Lower wall? Okay, so it does say the bottom plate is moving at -2 meters per second. Okay, so the absolute speed is 2 meters per second, and it's moving in the negative x direction. Okay, that's the lower wall. Yep. Upper wall boundary. This is what's different than our other projects, is before we would have stationary walls. Right, the top plate is said to be moving 3 meters per second in the positive x direction. And that's good. So that should be all of our boundary conditions. So let's do the initialization. Initialize. And we're going to go to run calculations. I like the sound of 1,000. Calculate. Alright, so it says calculation is complete. So now it's time to give a look at our results. So let's do the first requirement of the project. This is to show velocity contours with vectors, zoom in on boundary layer. So we're going to go ahead and take a look at our velocity. It's okay, we'll just select all like this. Yeah, this is velocity, right? Yeah. So save and display. Okie dokie. Go to our vector, right? And we have all of the same things. Go ahead and check it. Make sure everything looks good. Yep, this is exactly what we're wanting to see. Right, and now we're going to go to scene, and we are going to compile both of these together. Maybe halfway. I think that's pretty good. Alright. I'm going to go ahead and take a screenshot of this right here. Probably there's that one. The next part of the project says show pressure contours. So that's going to include static, dynamic, and total. So we're going to go back to our contours. And I'm going to create a new one. Pressure, static pressure. And we're going to use all of these. Save and display. Yep, and it should look something like this. Very rainbow. Very rainbow. Let's make another one. Dynamic. With all selected. Okay. And this is what our dynamic looks like. Really cool and interesting. Let's see, comparing the beginning to the end. It's also interesting to look at the top layer, because that's also existing as well. That top layer there. One more contour of total pressure. And again, grab all of these, close it. Hopefully this will be good. Okay, so those are all pressure contours. So 3 pressure contours. We got the velocity contours with vectors. Now it says show velocity profiles at the mid and end section of the pipe on the same graph. Okay, so this one is going to be a plot that we are going to make. Okay, and something different is it specifically asks at the mid of the midpoint of the pipe. So we are going to have to make a line. Okay, and this is going to be the midpoint. It's a line. So start of the X. So we made it 300 millimeters long, which means it's going to be, I'm blanking. Okay, we made it 300 millimeters long, which makes it 0.3 millimeters. And then we're going to do half of that, so it's going to be 0.150. Okay, for both, because we're doing a line straight up and down, so that all that's changing is the Y value. And then Y value is going to be 0 for the first one, and then we made it 2 millimeters tall, which means that this is going to be really tiny. So if we move this one, create that and close, and then it also wants us to do the end section, so we are going to make another point. Yep. Okay, so we are plotting the velocity. It's going to be on the x-axis, or I mean the y-axis. Velocity, and it's going to be midpoint. You're going to want to click. And I never renamed this. That's my fault. But line 6 is the line that we just made for the end. Okay, so now I'm back. I saw a little bit, something that was a little weird to me about the graph. But all I did was you go in, you make your points like I explained previously. The only difference that I made was making this into x velocity instead of velocity magnitude. And then that's going to give us this right here. Okay, and I am going to go ahead and snip this guy. This is what we're looking for. So determine, okay, show velocity profiles at the mid and end section on the same graph. Good, we got that. Got that out of the way. I'll close this. Next step is to determine maximum velocity and the height at which maximum velocity occurs using Fluent results. All right, so that next step is going to be in reports. Report type, vertex, maximum velocity, yeah, maximum velocity, and I'm just going to click everything, and there we go. And so that gives us the maximum velocity, which is going to be 7.46 blah 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 meters per second, and that will be the maximum velocity, which also correlates to the maximum velocity seen here, right at this midpoint and endpoint graph. It shows us these two values right here, the x velocity, and these are actually the maximums. So you can see right here, it's like right there, 7.4. I think it's rounding up to 7.47, but yeah, that is also showing an example of what the maximum is here. max height is going to be this guy. It's going to be at 1.17 times 10 to the negative 3. So that is the position that that's happening. And let me bring this over here so you guys can see. The last part it asks us to do is determining the pressure gradient with the theory. That I am going to be submitting my handwritten work for. So, yep, that should be just about everything. That is it. So I hope it was helpful. I hope it was useful. Like I said, that part E I'm going to be completing on the paper. So, yeah. Bye.